Hello and welcome. So we're going to be talking about similar triangles today. So before we get into it, let's talk about similarity for triangles. There are three different ways to prove that you have similar triangles. The first is angle, 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 similarity. The next is side, angle, side, and side, side, side. Okay? So when you're talking about two triangles, doesn't matter what two triangles you have, right? If you have two triangles and you know that we call it angle, 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 but honestly, if you only have two of the three angles that are the same, that's all you need for angle-angle similarity. So, for example, if you knew this one was like 20 degrees, and you know this one was 20 degrees, and maybe they both had a right angle, at that point, because of your angle, like triangle, the interior sum of all triangles, you know that that third angle is going to be 180 minus the 20 minus the 90, which in this case would be 70. And that would be true for both triangles. Now, on similarity, all you need to know is that once those angles are the same, at least two of the three angles, then you know that because of the triangle angle sum, you know it's going to be matching that triangle angle similarity. Okay, for side angle side, it's a little similar where you're looking for two sides that are not the same but proportional. So what that means is, well, I actually have an example right here. So side angle side. We look at this when I'd say, okay, what we're given two sides and an angle between them. Now this is very important. We call it side angle side because we notice the angle is sandwiched between two sides. That must be the case. If this was something like you had a triangle and maybe this was the 11, this was the 18, and maybe the 50 was in this corner, that would no longer be side angle side. That would be side side angle because you have side side angle, right, in that order. And that wouldn't be able to do anything for similarity. Okay, that wouldn't be enough to prove anything. So the angle must be between the two sides. Alrighty, so what we mean when we say proportional sides is you say, okay, well, pick a triangle. Right, small to large or large to small. You got to stay consistent with what you pick. I like going large to small personally, so that's what we'll do. So first thing I would look at is I'd say, okay, well, we have corresponding sides. So the large side, 18, is the larger between 11 and 18, right? And 45 is the larger between 45 and 27.5. So you'd say, okay, well, we take 45 divided by 18. 9 is the common number here, right? 9 goes into 45 5 times and 18 twice. So that means that our proportion is 9 halves, right? You take 18, you multiply, sorry, not 9 halves, 5 halves. Multiply 18 by 5 halves, we get to 45. Now, if these are similar triangles, then if we multiply 11 by 5 halves, that should give us the 27.5. Now, another way to check that is if you just do 27.5 divided by 11, we should end up with 5 halves if it's similar. So let's just double check. So if we have 27.5 divided by 11, we end up with 5 halves. And because they match, right? They're both 5 halves, and that is truly what we needed to do for that proportional sides. Here is your proportion. They are the same, which means that your two sides, those are proportional. That satisfies similar triangles. Now, the last thing you need to double check is we need that angle to be congruent. 50, it matches both triangles. That's all you need for side angle side. Okay. Now, if it was side, 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 then you don't need to be given any angles. You just have to be given a third side for your triangle. So for this one, I don't know. Maybe this last side is like 9 or something. Okay. And if we wanted to check, our similarity, then you would just take your other side of the triangle, which we would have to have been 22 and a half, right? And then you would do the same thing. You would set up that proportional 22.5 divided by 9, which would give you the last 5 halves. Now, in order to do side, 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 you would have to have all three sides giving you the same number. Remember, it's really important that when you're checking these proportions that you're setting them all up the same way. So you'll notice that I did the bigger side on the top for each one of these fractions and then the smaller side on the bottom. you can't switch that up, right? If you put 9 over 22.5, that will give you 2/5. Clearly not the same thing as 5/2. So you got to set it up the same way. It's either every side from the large triangle to the small or small to the large. Doesn't matter which way the triangle proportion goes. Just make sure you're consistent with what you pick. And that is all of your similarity statements. How to prove similarity, right? Whenever you're looking at similar triangles, look at what you're given. If you're given two sides and an angle, try for side, side, side. If you're only given angles, try for angle, angle similarity. If you're given three sides, try for side, side, side. Okay, if you're given anything that's not going to give you any of these, then you're out of luck, right? If you're given everything, if you're given all of the angles and the sides, then pick which one you want to use. Alright, thanks for watching.